Welcome this afternoon to a discussion of hydrogen flow and treat market niches. The market for hydrogen is a very interesting and rapidly developing market in that we have all sorts of different technologies, applications, and needs and interests for using hydrogen as a fuel. So the opportunity is certainly somewhat uncertain because of all the different variables, but the McIlvaine company is following this on a daily basis and publishing weekly alerts, the utility e-alert, with the latest information on the use of hydrogen for the power industry. So the sales of flow and treat products to produce hydrogen in 2050 could range from 15 billion to 50 billion. So it's going to be a considerable market. The market, to some extent, will be shaped by the suppliers. Other methods of energy storage, for instance, will compete. To the extent that the flow and treat industry can improve the economics of hydrogen, the larger the market share for this fuel option will be. Individual flow and treat suppliers will need to determine their specific potential revenues and EBITDA depending on several variables, including the total amount of hydrogen consumed, percent used in different industrial sectors, sources of power, geographical distribution, and the technologies used to make the hydrogen. And the end use in 2050, as you can see here, is electricity would be only one of a number of uses for it, including cement, steel, chemical industry, obviously transportation, on the road, aviation, and shipping, all are potential markets. So the energy source to produce the hydrogen has significant impact on the size of the flow and treat market and the competitive position of specific flow and treat companies. Some suppliers, such as Andritz, with strengths in hydropower, is going to benefit from the potential of using hydropower, which in many cases is not strategically located to provide electricity directly, and hydrogen may be a more convenient way of utilizing that energy source. And wind and solar, of course, is a big potential driver for the electrolyzers and that aspect of it. Bioenergy is a very interesting opportunity because you not only can produce the hydrogen, but using a biofuel, you're actually taking the CO2 out of the air, so it becomes a carbon negative approach. And municipal sewage is an interesting potential, a very big potential. Municipal solid waste is, could be 1 billion tons of CO2 removed that way. Food waste, and of course, nuclear, coal, and wind and solar we've already discussed here. So hydrogen can be transported as a gas, a liquid, or as ammonia. The liquefied hydrogen or as ammonia. The choice of ammonia as a method for transport has a number of advantages and is being pursued as a blue hydrogen approach. Ammonia can be produced in Australia with CCS to eliminate the CO2 emissions and then shipped around the world. So a number of flow and treat companies specialize in products for ammonia manufacture and transport, and they will benefit to the extent that this ammonia option is selected. The achievement of net zero will require 306 million tons of green hydrogen derived from renewable energy each year. according to IEA. So the IEA sets out the steps needed to get the world to net zero emissions by mid-century and says that 197 million tons of blue hydrogen would be required annually, derived from natural gas or coal with carbon capture and storage. We have another analysis, which you can also view and hear, where we believe that the BECCS will be a much bigger part of this mix, and that you'll be able to generate hydrogen from that. The electrolytic hydrogen is going to be huge, and but the problem is going to be getting enough electrolyzer capacity, and you've got the catalytic membranes and other components that need to be ramped up to provide as much as 3,500 gigawatts of electrolyzers. So this is a huge increase from about 300 megawatts of electrolyzers today that are available. So electrolyzers is a key aspect of all this as well. So it's interesting to see the IEA breakout, which views all the ways we will need to introduce various different fuel electricity sources in order to power sources in order to reduce greenhouse gases to a net zero per year. And the problem is that there are going to be some uses that are going to be emitting CO2, and they have to be offset with some carbon negative applications. So bioenergy is part of the mix as IEA sees it, with 640 gigawatts of bioenergy being required to meet net zero for the world. We have another analysis that shows that this could be 2,000 gigawatts, and that some of these other approaches would be reduced. One thing to keep in mind here with what we're looking at is the capacity factor. So a coal-fired power plant converted for bioenergy would have a 60 or 70% capacity, whereas solar might only have a 25% or 10% capacity factor. So you've got about 14,000 gigawatts of solar, but the actual output is going to be the equivalent of 3,000 or 4,000 of bioenergy coal-fired sources, for instance. So coal-fired capacity with CCS is estimated by IEA at a couple hundred megawatts. So these are some of the numbers that they have put out here. And again, the hydrogen would play a major role, as you see here, with 1,867 gigawatts of hydrogen being produced. So it would have a number of different uses, heavy industry, of course, power. Road transport is the third largest demand for hydrogen. And then you've got aviation, and you've got shipping. So this is a big program. Japan is stepping up to it, and because of their more remote location, they're looking at the import of lots of ammonia, 3 million tons of ammonia a year just by 2030 in one contract that they are pursuing. A part of that's going to come from Yara, and as we discussed before, with Australia as a source of the ammonia. So Yara is the world leader in ammonia with long experience and leading positions in the global ammonia production. So one of the options is ammonia co-firing in Japan. and that is being pursued along with some of the other opportunities there. So just to give you an idea of what we're doing here on a weekly basis in our utility tracking system, here's just our August 13th alert. We do this every week. So Howden's got a green hydrogen contract and compressors for another plant there. So you've got wind-based green hydrogen at a 1600 megawatt Hamburg plant. You've got a 10 megawatt electrolyzer starting up. You've got sponge iron using hydrogen. So here's another hydrogen capable turbine in Australia by GE, and Plug Power is producing green hydrogen in Georgia. BP is looking to export green hydrogen from Australia. JM is manufacturing the components for the green hydrogen. And again, this is a critical aspect because you've even got questions about the platinum and other metals, but JM has the ability, it's the largest secondary smelter in the world, so the platinum supply can be regenerated. And Haldor Topsoe has a process that is used for separating the hydrogen, and Doosan is developing ammonia hydrogen turbines. Cummins and Chevron are working on hydrogen for transportation. Linde is starting up its 5th hydrogen plant in the U.S. And Mitsui and CF are looking at blue ammonia development in the United States. CF is a big fertilizer company. And so this was the week before, looking at the Hydrogen Next conference and Trillium successes, large transit fueling station in Santa Ana, California. Trillium is big with hydrogen, is very active in hydrogen fueling stations. So that is another opportunity here on the mobility side. And then looking at some of the suppliers, you've got Sundyne, who's got the pumps and compressors. And in all these cases, it turns out to be a question of the unique capabilities of particular components. So, is the Sundyne PPI compressor, does it have advantages, lower total cost of ownership for this particular process? And then here are some additional articles that appeared in each of the other weeks. So we're continuing to do the utility alert on a weekly basis, and we do have details on all the coal-fired and gas turbine plants around the world. We're also reporting, on nuclear and, of course, all the biomass and hydrogen activities. So the tracking system is available along with the gas turbine and system as well. And this is all available for a package price of $3,800 a year for all of this. And we also do a customized forecast for hydrogen opportunities for any product in valves, pumps, compressors, combustion systems, etc., filters, chemical scrubbers. And those are available either along with our standard reports or in addition to or as a substitute for our standard reports if you just want to focus on hydrogen. And we have market share data, cost of ownership analyses, and so forth. And this would be quoted on a special basis. I'd like to thank you for spending some time learning about what our activities are in hydrogen. We think it's a big and growing opportunity and look forward to working with you in the future. This is Bob McIlvaine signing off.